Okay, good morning, everyone. Today, my plan is basically to review with you for the exam. I put the review on Brightspace, as you guys know, and I will appreciate it if you guys ask me questions about the review, the one that you had difficulties with. Your quiz was not very good this time. Usually your previous two quizzes were very good. This one was not. And this material will be highly represented on the exam. So as you guys know, I put feedback to each one of you on your quiz, what was wrong, and the solution is on Blackboard. Sorry, I meant on Brightspace, but I still would like to talk about it because your exam is coming up. And if you have any questions about the review, you put them on chat. It will help me tremendously, and I will answer every one of them. Okay, so before I do that, let me talk about one thing that I wanted to be very clear before I start the reviewing. So compare the functions, sine t, 2 sine t, and sine 2t. I'm taking something very specific. What's the difference between those two functions? It means this 2, how is affecting the picture in the problem? So we have to be very, very clear. So I'm just going to pick up values to make it, hopefully very clear. Sine t for a different value. Okay, what's sine of 0? I want answers very quickly. Sine 0, I'm listening, I'm reading. Anybody? Okay, sine 0 is 0. Sine pi over 4, anybody remember that? Don't make me ask you. This is a value that you should remember, square root of 2 over 2. Okay, sine pi over 2, quickly. That's easy. Think of the unit circle.
Juju, come on, move.
Oops.
Move, go.
Yes, go. All right. Sine pi over 2, quickly. 1, because if you think on the unit circle, the sine of pi over 2 is right here, the sine is 1. 3 pi over 4. If I know pi over 4, 3 pi over 4 quickly. Please hurry up.
Square root of 2 over 2?
Exactly, because of the symmetry. Nothing changing. Pi, quickly. Pi, no. Yes, of course. 3 pi over 2. I am down here very quickly. Minus 1. And 2 pi, I'm back here. 2 pi will give me the 0 again. Okay, so that's the sine values that we've done that. And then the graph starts repeating itself. What's the effect of multiplying 2 times sine? How is this affecting the value of the function? If t is 0, the only thing I'm doing is I'm multiplying the sine of 0 by 2. But we know what the sine of 0, it's 0, so this is going to give me 0. So I'm multiplying the output by 2. Here, I am multiplying. That's really what we are doing. So whatever sign take, this is multiplied by 2. So it's multiplying the outside. Whatever sign does at pi over 2, this new function will multiply it by 2, which is going to give me 2. So every value is stretched by 2. Multiply this by 2. Multiply this by 2. That's the only thing I'm doing. I'm multiplying by 2. Multiplying by 2. Multiplying by 2. So multiplying the sign by 2 is in fact, whatever sign does, you take its value and you multiply it by 2. However, so if we graph it, before I reach to the last one, what's going to be the effect graphically? The effect graphically would be the following. The sine, we should by heart know it. That's pi, 2 pi, pi over 2, 3 pi over 2, and that's my 1. So the sine, we know it goes up. Sorry. Okay, that's my pi, so that's halfway through. So it's going to go up to 1, go down, go up. That's the sine. And that's 3 pi over 2. Now, so that's the sine. What does the 2 sine do? The 2 sine is, whatever the value of sine is, you multiply it by 2. 2 times 0, 2. Right here, it's going to multiply it by 2. At pi over 4, multiplied by 2. So the output is totally multiplied by 2. So I'm not touching the period. I'm just stretching it by a factor of 2. So that's the 2 times the sine of t. So I don't change the period, and that's crucial. The period remains the same. I'm just stretching the output. So multiplying by 2 only stretch the value of the sine. Does not touch the period. The period is always 2 pi. However, what's the effect of sine 2t on the graph? What does sine 2t does? Okay, let's go through that. At 0, that's the sine of, if t is 0, it means you're multiplying 2 times 0. It remains 0. But what happened at pi over 4? Watch carefully the effect. It's the sine of, if t is pi over 4, this is going to be 2 times pi over 4. So this function takes at pi over 4 what sine take at 2 times pi over 4. It means 2 times pi over 4, it means pi over 2, which is 1. So when I multiply this by 2, this function is going to take at pi over 4 what the sine took at pi over 2, which is the 1. So totally changing the input. What's going to take at pi over 2? It's whatever sine take at twice pi over 2. It means at pi, which is 0. So the whole thing is picture. So when I'm going to graph this function, which I'm going to graph it in, it's supposed to be purple. What's happening? At 0, it's going to take 0. At pi over 4, it's going to take 1. So at pi over 4, it takes what the sine takes. At pi over 4, it's going to be all the way to 1. So it takes at pi over 4 what the sine takes at pi. It's going to move the sine this way, shrink the sine. And it's going to go all the way up to here. So it's at pi over 4, which is taking the value 1. Then what does it do? At pi over 2, it's taking the value of sine at pi. So at pi over 2, right here, it whatever the sine take at pi, it's going to take here. So it's going to bring it all the way down. It's really, the amplitude isn't changing. It's really the period. It's taking the sine and actually compressing it. Then what does this do? At 3 pi over 4, its value is the value of the sine at 2 times 3 pi over 4. Because you're multiplying by 2, it means the sine at, if I multiply those, at 3 pi over 2, which is minus 1. Means if you are at 3 pi over 4, which should be somewhere in here, what this function take, the purple one, is what the other one take at minus 1. So the minus 1 is going to be shifted here. And the sine 2t will take at pi what the sine took at 2 pi. So this, we're going to be back here. And after that, it will start repeating. So that's really the effect of this function. So multiplying the input, this one by 2, Its effect is taking the period and actually compressing it in this particular scenario, because the all output is changing. Okay, so you have to be very careful whether multiplying the outside by 2 versus multiplying the inside by 2. Multiplying T input by 2 affect the period. Multiplying the outside by 2 affect the amplitude. All right, so with this in mind, I will go over your quiz and make sure you understand your mistake verbatim, okay? So, because your exam is coming up, and this will be, as I said, pretty much. So the rule was in general the following, and you have to know how to use it. So the rule was the following, because why we give you the rule? Because it's hard every time to figure out the problem. So the rule was the following. Function that has the form a sine bt plus k or cosine. They are very parallel to each other in terms of value. Okay. Multiplying the sine, the outside, by a constant, this is affect the amplitude. So that's why the amplitude is the absolute value of A. Multiplying the outside, stretch vertically or horizontal, stretch vertically. Multiplying T by B, that's what affect the period. So the period will be 2 pi over B. It's multiplying this by B which affect the horizontal. The shift is easy, that's the midline. Nobody has problem with that. Okay. Now I want to make comment, easy comment here. The period is 2 pi over B, and B is actually 2 pi over the period. Why is that? Does this make sense? Does this make sense? Algebraically. Let me make sure, what? Does this make sense algebraically? If the period is 2 pi over B, and I find the B, it means the period. I multiply by B, both sides is 2 pi. So that sometimes make the math very easy. It means the B is the 2 pi over the period. So this will make it a little bit easier for you to find the B if you have the period. So this is the general formula. And with this formula, we're gonna go over your quizzes very slowly. And I will point out every mistake you've done, so none of the mistakes will be repeated. Okay, so the first question was, for each of the function below, find the amplitude, the midline, and the period. All right. Amplitude. This piece is the stretch, vertical stretch. So the amplitude is 4. Okay. Now, the midline is the shift up and down, and adding 3 shifted. So midline y equal to 3. What changed the period is multiplying t by a constant. So, and this is where the difficulties came. So the period is, so the b here is a third. The period is 2 pi over a third. And now let us see the algebra here. What is the algebra? How do we divide by a third? It's 2 pi. You multiply by the reciprocal, which is 3 over 1. And that should give you a 6 pi. So the period here is a 6 pi. And that's where a lot of the student had issues with the algebra at this stage. Part 2, B. Again, that gave us a lot of trouble. What is the y here? The first thing is that to be able to figure out amplitude shift, I have to write it in the standard format, sine bt plus k, so I can see the picture. So the this what the way we're doing it is over 4 minus 5 over 4. Okay. All right. So the amplitude here, so I'll rewrite it 3 in a clearer way, sine t minus 5 over 4. Okay, one of the mistake is that some student did not divide across by 4. So they had this, which is wrong because this will make the shift to be 5, which is wrong. Some student ignored the 4 totally and gave me an amplitude of 3. So all these are issues you have. So the amplitude is by how much we stretched vertically, or that's the amplitude. The shift, the midline is the shift, the vertical shift. And the period. And that's where the word struggle. What's the period here? Back to you. What's the period? Please speak up.
I actually just have a question as to where I got confused with the period on this.
Yeah.
So I assumed that with t, it was technically 1t, and therefore when it had everything divided by 4, it would be 1/4 t. And so I ended up getting 8 pi, which was wrong. I was just wondering why it wouldn't be 1/4 t.
Okay. Let me take, that's the mistake that actually surprised me, but then I realized it was repeated. So a few students did the same mistake. Why it is not 4th t? Let me ask you the following question. Is sine, what I did at the beginning of the lecture, then I got to your question. Is sine 2t the same thing as 2 times the sine of t? Question, true or false?
It's false.
Absolutely false. What does this do? Take the graph of sine, change the period. This one, it will stretch it. Are you with me?
Yeah.
Yeah. Or another way you can see, what does it mean for those to be equal? It means I take the same value for each value of t. So suppose I take t to be, let us say, I don't know, pi over 4. Will this take the same value? No, because this one is 2 times the pi over 4. It means the sine of pi over 2, which is 1. However, this, it takes 2, you multiply it by the sine of pi over 4. So very different function. They are not the same. This one has amplitude 2, this has amplitude 1. Okay, now, question number 2. Is the sine of t divided by 4 the same thing as the sine of 1 over 4t? Everyone, the question is addressed to everyone because a lot of you did mistake here. Are those two the same? Means, can I put this 4 inside? Yes or no? Who say yes? Who say no?
I say no.
Because?
Because the 4 is being, this whole sine t function is being divided by 4.
Right.
That's not the same as 1/4 being multiplied by t.
Right. This one is basically 1 over 4 multiplied by the sine of t. That's really what it means. It's like if you have 3/2 or 3/4. What 3/4 is 1/4 times 3. And that's exactly, sine t is a number depending on the value of t. So that's 1/4. However, this is that. They are really very different from each other. This one is the sine t, where everything is multiplied by 1/4. So this takes the sine of t and shrink it and has amplitude 1/4. This one, it doesn't shrink the sine vertically. It actually affects the sine horizontally because you're multiplying by 1/4. So those are two different functions. What's the period here? The period here is 2 pi. You're not changing the sign. You're just changing the amplitude. The period is absolutely 2 pi here. The period here is 8 pi. Okay? Anybody, the person who asked the question, is it making sense?
Yeah, it is. I guess just for clarification, don't think of when it says sine t, don't think of that as sine of 1t for future reference.
It's 1t. It's 1t, yes. This one is 1t. You're not affecting the t. So the period is going to be 2 pi. 2 pi over 1 if you want, but it's 2 pi.
Okay.
Okay? Nothing is affected. This is the period. So for your answer, the period is 8 pi for this scenario when the t is multiplied, but not the t here. The sine here is multiplied by 1/4. Jacob, do you like to speak up? So in this
Yeah, I'll
problem,
speak up. I apologize. I was typing. I was going to say that I got that wrong too. And I realized after the fact of when I looked at the notes is because if it was going to be divisible by 4, then they would have had it divisible by 4 in the parentheses.
right. Yes.
So the fact that the division by 4 is outside the parentheses makes the 1 inside of the parentheses immune from the division by 4.
Absolutely correct.
So-
Absolutely correct. So we have to be very careful.
Following,
Yeah, we have to be
yeah,
very
following
careful.
him.
That is multiply. Yes. Yeah, you're right. So the period here is not affected. The period is 2 pi. Nothing. It's sine of t. It's not of 1/4t. The 3/4 is multiplied outside by the sine, not inside by the sine. And that was the very common mistake in class. And that's why I have to address it. Okay. Anybody has any questions about that? So it's just the sign here, nothing than the sign that you're stretching it. Actually, you're shrinking it because the amplitude is 3/4 and 3/4 is less than 1. All right, now part 2. Again, there were issues with that and issues with graphing, and we have to address that. So find the amplitude and the midline, the period, and sketch the graph of the function below over 2 periods. So I wanted to sketch over 2 periods, and then the coordinate of the point where the function reaches its max value. So we're going to go every piece of it. So here, the amplitude. It's by how much you stretch your sine. So this function, you stretch it by basically a 3, but then you reflect the sine. So the amplitude is not -3. Some students put it -3. The amplitude is the distance between the midline and the maximum value. That's the amplitude. The +2 is the shift. So the midline here, y equal to 2. Okay. Now the period. Now the period, of course, is not pi here. So the b here is pi. The period, and because the reason we memorize the formula, because it's hard to figure it out every time. I mean, even me who understand this stuff very well, usually I use the formula because it's not always easy to figure it out. It's 2 pi over that, which is it 2. It means the graph of this function will have to repeat itself every 2 units. So let us see how the graph is going to look like. Okay. So the midline is 2. So that's the midline. That's the halfway through. That's 2. Okay. Now, this is like minus sign, but the amplitude is 3 and it's reflected. And the period is 2. That's my period. So I usually like, whenever I have the period, I divide my picture into 4 pieces because we know that's what's going to happen. So it's a sine. We start at the midline. There is a minus in here. This tells me that you have to go down. How much you have to go down? By the amplitude. So if this is 2, I have to go down, and this should be the 3. That's the amplitude. And then I have to go up, and then that's the graph of sine. And then at this point, I have to go up, back up, and then up to 2. That's 1 period. And then I have to repeat myself. I should have left more room. That's my mistake, not yours. So that's 4, it should be. And then it should verbatim repeat itself. Exactly. And in the solution on Blackboard, on Brightspace, I meant, it should be much clearer. That's a 4. Okay. All right, so that's the period. That's the amplitude. That's my 3 from here to here. And that's exactly look like the graph of sine, but minus sine. That's why I have to reverse it. And this is the 2. 2 is the period. After that, it's basically you're taking this graph and shifting it. That's really what happened after that. So now I want the coordinate of the function where it reaches its max. It reaches maximum right here, and it reaches maximum right here. And my goal here is really to be able to see, can you understand really what's happening in the picture? If this is the midline, it means this is, we are halfway through. That's the 1. Okay. Where the peak happen are always the halfway. So this is going to be the half, and this is a half. So this is basically 1.5 right there. And then the picture continue. Like right here is 2.5. Right here is a 3. And right here is 3.5. Because the way the graph works for the sine, so the way, for the sine, the graph works like this. And I mentioned this. So those are all equal to one another. That's really how to graph the sine. So if the period is 2, it means this should be 1, this should be a half, and this should be 1.5. That's how it works. And the max will occur right there. Now ours is the same thing, but it's shifted by a factor of 2. So this point here is going to be 1.5 and 5, because I have 2 here, and this is a 5 up here. And this is going to be 3.5 and 5. End of the problem. Okay. So the mistake here showed up with graphing over a period, not really realizing exactly how the period is. Right? Okay, so we're going to finalize those. And this is like the review, actually. Doing those is basically also going through your review. And now here the question is, find the period, the amplitude, the midline, and then a formula. So to find everything, usually I like to draw my midline because it guides me. So this is my max here. It's 2.5. My minimum is 1.5. Okay. So the amplitude, some of students had a mistake. The amplitude is half the distance between max and mean. So from here to here, this is 1. The amplitude is the halfway, which is a half. So the amplitude is a half. And if you ever forget what it is, you just use the formula. It's the max minus the mean divided by 2. That's give me the amplitude. Now the midline is this line right here. It's the line halfway. So I draw the midline. I always draw it because it guides me. It tells me what's really going on in the picture. That's the midline. It tells me it's a sine. Is it a cosine? It really tells me the whole story. That's my midline. So my midline is y equal to 2. If you ever forget the midline, it's the max plus the mean divided by 2, which will give you 2.5 plus 1.5 divided by 2, which give me 4 divided by 2, which is 2. So that's the midline. Very good. Now, the function look like a sine function. So that looks like sine. Okay. And the period is, the period is, let us see, it starts here, it's going up, down, and then it's actually start repeating itself. So it starts repeating itself right there. So that's the period from here to here. Some student again had difficulties with the period. So the period is pi over 8. Okay, but now what's the formula? So what's the general formula? And then we're gonna fill in every detail. So the formula is going to be the amplitude. This is a sine graph, bt plus k. Okay, now what's each one of them is and where you guys had the mistake. The a in this case, because it's exactly like the sine, is going to be the half. Okay, now we're shifting up by 2, so k is equal to 2. Okay, nobody as a whole had difficulties with that. The difficulty came here. B is not the period. So the B here is not the pi over 8. What's the B? It's 2 pi. That's the easiest way for you to know, divided by the period. It's not pi over 8, and that's what a lot of you actually did. So this is going to be 2 pi divided by pi over 8. And now fraction come into the picture. So that's going to be 2 pi multiplied by 8 over pi. Because how multiply or how divide fraction multiply by the reciprocal, which is going to give me the pi simplify will give me 60. And the formula will become, it's like sine. So it's going to be 0.5 or 0.5, either one is accepted, sine of 16t plus 2. And now if you graph this function, you get exactly that. The period of this function is the pi over 8. Okay, so the period is not, the b is not the pi over 8. The b is 2 pi over the period. Now this one will have this as a graph. And that's where a lot of you actually messed up on this particular problem. Okay. So I will do this and I will do 2 problems along those lines and I get back to your review. So this is really against the same issue. I need the amplitude. So from here to here, 7. So this from here to here, I have a 4. The amplitude is half. A lot of students also told me the amplitude is 4. So the amplitude is max minus mean divided by 2. 7 minus 3 divided by 2. This is equal to 2. That's the amplitude from here to here. Midline. Now, of course, we can see it from the picture. It's 3 plus 2. It's going to be 5. Or the midline is the max plus the mean divided by 2. Help you check your work. It means 7 plus 3 divided by 2, which is going to give me 5. I immediately draw my midline because midline is crucial to help me figure out what kind of a graph. That's my midline, and that's my 5. Okay, it's halfway through. Now the period. Okay, I start from here and ask myself, when am I repeating? Where do I start repeating? I go up, down, up to here. So this is where the cycle, this is the repetition. And then the graph starts repeating itself. So that's a cycle. So what's the period? If this is 3, this has to be 6. So the period is 6. I don't have to give you the exact value. I can give you a piece of it. You have to figure out the rest. So this is the period here is going to be 6. It's not 3. And the graph is like minus cosine. Because we're not starting at the midline, so it's not a sine. We're starting at the minimum here, so it's going to be minus cosine. And now let us pull the whole picture together. So the graph is going to be equal to minus the amplitude, which is 2. Cosine, I'm going to write bt, and then there is a shift of 5 because we're shifting upward, we're not shifting down. And now the b. Again, the b is not the 6. The b is the 2 pi over the period is pi over 3. So finally, my y equal minus 2 cosine pi over 3t plus 5. So this way, every one of you who did any mistake, hopefully you know exactly what mistake you have done. Okay? All right. On the review, actually, I would like to do one question that I haven't done. I mean, I've done it, but I didn't do part B. So any questions about the quiz? Okay. So I'm going to look up number 9 here on your review. I hope you guys, I mean, of course, you should have it. It's right there. And we will do number A, and then actually would like to go through part B with you just to make you more and more understand this concept. So A is the typical problem, midline, amplitude, period, and then give the formula. So work it out. Let me not work it out myself because I would like to do more problems. So I'm going to emphasize part B. So if you guys work it out, and then you're going to get that this function will have the following form. 20 sine of pi over 3t plus 25. And actually, if it makes sense, this is right here, the midline. And from here to here, I have 40. Halfway, that's the 20. That's the graph of sine. The period is 6, making pi over 3 plus 6. And the shift is 5 plus 20, 25. Okay, so that's going to be the formula. Now, part B, I'm asking you the following. Check that your formula agrees with the value of the function given by the graph for the following value of t. What am I talking about? This is the graph and this is the function. And the idea is that this rule should agree with your graph. It means if you plug in a t in your formula or in the graph, you should have the same answer. So let me see what I mean by that. For t equal to 0, what does the graph tell you? What should be the y value? And what does the formula tell you? And do they agree? Okay. This is the graph at t equal to 0. What does the graph gives you? Back to you.
Should be 25.
T equal to 0. The graph gives you 25. She is absolutely correct. The formula should give you the same thing. What do I mean by that? I'm going to plug in 0 in the formula and see if I get the same answer. If I don't, it means I am doing something wrong. It's 20 times pi over 3 times 0. It's a 0 plus 25. Sine 0 is 0. It's equal to 25. Formula, graph, agree. So that's really help you make sure that you're getting it right. I'm going to take another value. So t equal 9/2. at t equal 9/2, I'm going to do two things. What does the graph gives you? And what does the formula gives you? Okay, the graph. Can you guys see the graph? What's 9/2? 9/2 is 4.5. So what is 4.5 on my graph? Okay, Rebecca's giving me 5. Do you guys agree with her? If this is 3, okay, by symmetry, it means from here to here I have 1.5. 1.5, that's a 4.5. The graph gives me 5, absolutely correct. The formula has to give me 5. It means if I plug in 9/2 for t, I should get 5. If I don't, I'm not getting to the correct formula. So I will do it. 20 sine of pi/3 multiplied by 9/2 plus 25. You can use your calculator, but you have to get 5. Sine of. If I multiply this, I will have 9/6. 9/6 will give me 3 is a common factor, would give me 3/2. So that's if you do the math, you get 3/2 plus 25. So you give me what? 20 times. Sine 3/2 is -1 plus 25, which is going to give me 5. Check. The formula, the graph is giving you the exact same value. So that's really what I mean. It's a way for you to check that your formula fits the graph. So if you don't get the same thing, it means that your formula does not really represent the graph that you have in mind. All right. Okay, now part 10, those problems repeat themselves. And 11 is find the period. By now, I think you guys should be able to find the period. So very easily. So 10 is verbatim like 9, like the one I've been doing. Number 11 is find the period. So in this problem, what's the period? It's sine 4 pi t. Give me a period. All right. So it's going to be 2 pi over 4 pi. The period is 1/2. Correct. I want the period for B. Quickly. 6 pi, do you agree with her? I didn't do the math. Anybody agree with Rebecca?
I agree.
You do? It's 2 pi over 1/3. Be careful with your fraction. It means 2 pi times 3/1. 6 pi. C. Who can give me the period? Again, I didn't do it. I mean, I did it because I gave you this answer key, but I forget what I put. I want the last one. Three pi. Okay, let's see if she's right. The period is 2 pi. So here the B is 2/3 divided by 2/3. It means 2 pi multiplied by 3/2. Now I do fraction. So the 2 and 2 simplify, I will get 3 pi. So it's a lot of info. It means I have a function that repeats itself every 3 pi. Every 3 pi. It looks like sine, but repeat itself every 3 pi. Right. So I really want to close on this idea. Okay, 12, 13, 14, along the same line. Basically, so find formulas, Here, the formula is given. You need to find amplitude midline. So this is, I hope we've gone through that by now. Okay, number 15, I will look at it and then I will go to the other material. That's a typical Ferris wheel problem or population problem. Of course, you will have one word problem like that. In the Ferris wheel problem, the idea is to sketch the graph clearly. And then once you sketch the graph clearly, then you ask yourself, what's the amplitude? What's the max? What's the period? What's the whatever midline? And so on. And then you plug in the formula and you find it. Okay. Anybody has done the review that struggled on something? I doubt it. Anyway. So I look at number 15. So a Ferris wheel has 34 diameter. And it's 1 meter above the platform. So I have from here to here 1 meter. And complete revolution, 8 minutes. At the initial time, you are in the 6 o'clock position. So I am right here at t equal to 0. If h of t gives you your height above ground level, find a formula for h of t. You know, I don't memorize those. The only way I can do them is really be very patient. That's what I do. I take time and the height. I build up my table and figure out everything. And you guys, you do number 16. So at t equal to 0, every 8 minutes, we finish our revolution. So this is 0 and this is 8. Initially, we are 1 meter above. No. Then let us say, it doesn't matter how you move it. Suppose it's moving this way. And here it's going to be at, that's t equal to 4. At t equal to 2, I am 1 plus 17. I am at 18. At t equal to 4, I am at 1 plus 34. I am at 35. This is at t equal, now at t equal to 6, I am back to 18. And t equal to 8, I am back to 1. Okay. So you always start by figuring out those numbers. You don't graph first. Then after you do that, you start the graphing period. So this is my period 8. So the problem is becoming now repetitive. That's my 4, my 2, my 6. I'm going to start at 1. Right here. Then I'm going to go up to 18. And then I go up to 34, 35, back up to 18, back up to 1. So I'm going to have this kind of a graph. And then I will repeat. So now I need to find a formula for this. And then I'm going to ask you a question. So what's going to be the formula? I need amplitude. So now this is my 18 here. And this is my 35. So my amplitude is going to be halfway. 34, 17. Midline is going to be 18. Period is 8. Graph like minus cosine. Okay. And then formula is, so the B is going to be 2 pi over 8, which is going to be pi over 4. In radian, everything here in radian because I'm looking at 2 pi. So the height is going to be equal to minus 17 to cosine pi over 4t plus 18. Question number 2 is, find the height of the Ferris wheel above ground level after 30 seconds. So height after 30 seconds. Okay, what am I asking for here very quickly? So that's my Ferris wheel. Moving up. I want you to ask you, okay, this is equal to 0. Now I know that after 2 minutes is here. After 30 seconds, how high I am above? What do I do? Quickly, so I can review more with you.
Can't you divide the height at 2 minutes by 4? Right?
Repeat what you said.
I said, can't you divide the height at 2 minutes by 4? Since you're trying to find the height at 30 seconds.
So what do I do?
Wait, what do you mean? Like, okay, we know that the height at 2 minutes is, what was it? 30, was it 35? Right.
After 2, it's 18.
Okay, so at 30 seconds, wouldn't the height be 4?
And the answer is no,
No?
because the height does not go up by the same amount all the time.
Okay.
The height will not change by the same amount because we are curving. So the height will not change by the same amount. Let me see if I can explain it in a clearer way. So this is your, okay? This is your Ferris wheel, right? At t equal to 0, I am here. And at t equal to 2, I am here. Okay?
Okay.
All right. Now, exactly. After 1 second, where should I be? After 1 minute.
You should be halfway between t equals 0 and t equals 2, right?
Okay, halfway.
So, right? Yeah.
Now, is the height the same?
No.
Absolutely not, because you are curving. So right here on the arc, yes, we are halfway here, but the height, because this is curving, the height is not equal.
So,
You understand what I'm saying?
yeah, you would plug so into the y equals
Right, we have to plug it into the formula. That's the
right.
goal of the formula. Is that very clear? You don't
Yeah.
divide 18 by 4 because in 1 minute, the height is not the same. It does not grow linearly. It means the height does not grow by the same amount every unit of time, mainly because we are curving. That's really what's going on here. So the only way you can find the height, the only way is to plug it back into the formula. And that's the goal of finding the formula. So to find the height after, so if t equals 30 seconds, since my unit is a minute, so this is 1/4 of a minute because that's the unit in all the problems. So I have to take it into a unit. So it's good. Sorry, what am I writing? Half a minute.
Right. So we would
Apology. You have to put half right into this formula. So after half a minute, the height is minus 17 cosine pi over 4 times a half
right.
plus 18. And that's really the goal of this formula is any moment in time, if you want the height, you plug it back into this formula. And then this is going to be equal to, and now probably we need our calculator. That's fraction. You multiply the numerator over product of the denominator plus 18. And at this stage, there is only your calculator and somebody is giving me the answer. It's 2.294. And the unit here was meter. And this should be in radian. All right, so that's the only way you can do the problem. And that's really why we're finding the formula, because of the issue that one of your classmates brought up. The height do not grow by the same amount every minute. That's the picture. That's how you should see it. The first minute, we are halfway through, that's correct. But the height from here to here, the height from here to here are very different from each other.
I see. So once we find T, all we'd have to do is plug it back into
Exactly.
because
That's the goal of the formula. That's what this formula is actually giving us.
Okay.
All right. Now, when we come back after the exam, we're going to ask you, okay, if I want the height to be like 3 meters, what should be the time? We're going to reverse the process, but it's going to come after the exam.
Okay.
All right. Any questions?
No.
Okay. Number 16, you guys should do it. And it's along the same line. So I will let you guys work on it. And the solution is on bright space. So check your answers. All right, now what we're going to do is so I emphasized a lot the last part because your quiz was not good. So I want to make sure you get through that. Now the exam will, you go over number 8. Okay, I will do that, Rebecca, but definitely I will. The exam will be covering everything. So everything I did in the beginning till now. The tangent will be on the exam. So for that, I feel I have to remind you what the tangent is. I did that. I assigned problem. I hope you guys did them. So let us recall what's the definition of the tangent. And then we do the problem. Okay. This is my unit circle. That's a point. And that's an angle T. What's the tangent? Quickly. What's the definition of the tangent? I don't hear any voice. I don't hear any comments. What's the definition of the tangent?
Sine over cosine or opposite over adjacent.
Sine over cosine. In terms of the coordinate of the point on the unit circle, what's the tangent T? It's the y coordinate over the x coordinate. Okay, opposite over adjacent, this will have to wait. So that's really the definition that I want to become. That's the definition you will use as engineers. It's the sine over the cosine. That's why I'm emphasizing this tremendously. That's the definition that you guys will be using the most. Okay, and with this in mind, if I tell you find tangent of any angle, that should not be hard. It's the sine over the cosine. In this case, square root of 2 over 2 divided by that, which is going to be equal to 1. So that's really the tangent. Now, the graph of tangent, I will postpone that for later on. I don't want to put a lot on your mind. Okay, with this in mind, I will go through number 1, 2, and then number 8. I finish the lecture. All right, 1 is crucial. Given below is a unit circle. Fill in the blank with the correct answers in terms of A and B. So this is that's an angle theta, and this is A and this is B. So question number 1, what's the cosine of theta according to the picture? What's the sine of theta in terms of A and B? What's the cosine and what's its sine in terms of A and B? What's the cosine? The cosine y minus A. Theta is from here to here. So what's the cosine of theta? Is the x coordinate. Is A. Y minus A, Travis. Okay. The sine is B. So this is the cosine of theta. That's the x coordinate. And this is the sine. It's A and B. So the cosine and sine are the x and y coordinate. Cosine is the x coordinate and sine is the y coordinate. All right, with this in mind, what's the sine of theta plus pi, 2 pi quickly? That's okay. What's the sine of theta plus 2 pi? B, because this is theta, adding 2 pi, we come back to the same point. That's the periodicity. Nothing at all changed. That's the periodicity. T and T plus 2 pi repeat themselves. All right, B. What's the sine of theta plus pi? The only way you can answer this question is graphically. Theta plus pi. In terms of A and B. You guys want me to pick one of you, or you want to answer? Draw it. If this is theta, you're adding pi to it. This is theta plus pi. So what's the sine of it? Okay, that's the sine, that's the x-coordinate by symmetry. This is the minus b. Okay, what's the sine of pi minus theta? Again, unit circle. B, do you agree with them? Because where is pi minus theta? That's my unit circle. If this is theta, means you're taking pi and you're taking the same angle away from it. So it's equal to B. Cosine minus theta quickly. A. Because minus theta is down here. Same cosine. Cosine theta plus pi quickly. Minus A, do you agree? That's theta plus pi. So that's minus A. What's tangent theta? Using the picture I have. B over A, the sine over the cosine. What's tangent of theta plus pi? Don't guess. I don't want you to guess. I want you to think through it. It's what? It's the sine of theta plus pi divided by the cosine. We never change the definition. We never change the definition. It's the sine over the cosine. What's the sine of theta plus pi? Adding pi, the sine of it is minus b. Okay, what's the cosine? Minus a, which is equal to what? Minus minus, it means b over a. Okay, so tangent theta plus pi is actually b over a. Do not guess, just work out those problems. Finally, what's the tangent of pi minus theta? Now it's up to you. Do it as slowly as I am doing those problems. Okay, I'm looking. Yeah, I want more answers. Anybody else? I have one answer. Anybody else? Agree, disagree, what? Is she right? Is the answer on bright space right or wrong? Okay, I have two that agree. All right, so again, verbatim. What's the tangent? It's the sine over the cosine. So it's equal to, if you want, the sine is pi minus theta is b over minus a, or minus b over A. Okay. All right. Go over that carefully, not because of the exam, because those are crucial ideas to understand about sine and cosine. Number 2 is something I've done several times. It will be on your exam, that's for sure, and you have to go over them. So basically, it's the same ideas over and over. So I will pick one of them, for example, this one. And my question is, give me another angle beside 220, but it has the same cosine as 220. So I first draw 220. 220 is 100, like 220 is 40 degrees away from 20. So this is 40. That's 220. Okay, I want an angle different from 220 between 0 and 360 that have the same cosine as 220. Okay, you get a minute to do it. You don't need to memorize, you just have to use the picture. Okay, I'm waiting for answers. $140, do you agree with her? Okay. The picture is, I want a number, I want the angle such that the x coordinate of, so this is a P, I want a Q that have the same x coordinate as P. So using the unit circle, this is perfect. So I need this angle right there.
Right, it'd be the angle reflected over the x-axis.
Yes.
Right?
Why? Because I need the same x coordinate. The same x coordinate because I'm looking for the cosine. So this will be the question, the one I'm interested in. If I call the theta, so the angle I'm interested in is going to be 180 minus 40, which is 140. Total symmetry of the unit circle. Okay. So make sure you get all those correct. Now find the reference angle. When I tested you over that, you guys did fine. Check them. Find the exact value of each quantities. Exact value, it means I don't want 1.5. I want square root of 2 over 2. I want 3 halves. I want square root of 3 over 2. And we've done those. Again, go over them. Okay. Now, number 5, absolutely crucial. I mean, all those are the basic ideas of trigonometry. So I will take, for example, 6 and part C, for example. And the question is, find the coordinate of the point on the circle radius 3 determined by the angle pi over 12. So the main formula here you have to memorize or remember is the following. That's the heart of the definition of sine and cosine. If I am on a circle and the radius here is r, so that's the radius. And if I take any point on the circle of radius r, any point, P, if this angle is theta, then the coordinate of the P are r cosine, r sine. So this point has x and y coordinate. The x coordinate is r cosine theta, and the y is r sine theta. That's really what I want to emphasize in those problems. If it's the unit circle, then that should be cosine and sine. If the circle of radius r, and then we are stretching everything. So with this in mind, okay, I look at this problem. So here I have a circle. The radius is 3. And the angle pi over 12. So the angle is somewhere in here. That's pi over 12. And the question is find the x and the y coordinate. So the x coordinate is 3, that's the radius, times the cosine of pi over 12. And you guys will figure it out here. And the y is 3 times the sine of pi over 12, which is, you guys figure it out, okay? If I give you the angle in radian, your calculator has to be in radian mode. If it's in degree, make sure you are in degree mode. D is find the exact. When I say exact, it means I don't want decimal. I want those answers, something like that. And the unit circle will be extremely helpful in those situations. 6, 7, 8. All those deal with how to move back and forth between radian and degree. So you have to review that. And 7 and 8, I will of course look at it, is the following. The relationship between the arc length and the angle. And basically what you have to know is that if you have, this is radius r, this is angle theta, and if you take the arc cut by the angle theta, the length is r times theta, sorry, the length as long as theta in radian. Okay, that's really the main relationship. So if you know the angle at the center, you know the radius, you know how much you have from here to here. That's really the idea. Okay, so 7, make sure you do it. I'm going to spend a little bit of time on number 8 because that's what your classmate question. Remember, the exams start at 10:15. Does anybody has any objection with the time? What did I say? I meant at 10:45. Does anybody has any issue with that? All right. So I'm going to look at number 8. It's a bit hard, but why not?
I just want to clarify because I'm in a different time zone. That's 15 minutes earlier than class usually starts, right?
Yes, yes, yes. Everything is Hammond zone. I mean, Central Time. Okay. So when I say 10:45 Central Time, I have to stick to the time of the university. Okay, an ant start at the point 0.03 on a circle of radius r. So we have a circle. That's my circle. And the radius is 3. And I have an ant which is moving along the circle and walks 2 units. So the ant starts here. That's the point 0.03. And they start here. And it walks 2 units counterclockwise. So 2 units. Counterclockwise. Clockwise this way, counterclockwise. So it's 2 units. And stops right there. The question is find the x and y. So from here to here, that's 2 units. Find the x and y coordinate of where the ant ends up. So the ant ends up here. Let's call this point P. And the question is to find the x and y coordinate. Okay. Yeah, that's okay. So this is my problem. How I'm going to solve this problem. So basically, I want the coordinate of the point P. Anybody has any hints? Any ideas? So I want the coordinate of this point. The ant starts here, move 2 units, it stops. So I don't know, where is this point?
So S is 2.
S is 2, yeah.
Okay, so isn't it the radius times the arc length equals, wait a minute.
Keep going.
Wait, I'm trying to remember the formula.
You have to memorize this formula. I wish you guys were face to face. I would force you to memorize all this stuff. Ideas? So S is 2. From here to here, it's 2. The arc length. And this is 3. What does this give you? Anybody?
Means your arc length is multiplied by 3 because the radius is 3.
Yeah, but this gives you what, though?
Gives you the formula for theta.
What is theta? From where to where?
Theta is from the beginning of the x-axis 0 to your point.
No,
No?
no. Which theta it gives you?
Right, I was trying to say that theta of the
From-
arc.
From the y-axis to here. That's the angle that's cut off by this arc. Are you with me?
I'm with you.
That's the angle it gives you. So let me call it T. It does not give you from here to here because that's the arc. Right, so T, if you want to call theta, T is 2/3.
Right.
Not from here. Are you with me?
Yeah,
This one.
I misspoke.
That's
That's
okay.
all.
That's not the point. I don't care. I don't even know who's talking. Remember that. So don't worry about anything you say. Because I don't even know. So you guys can do all kind of mistakes you want. That's your choice. So this T is 2/3. Okay, so we're gonna have, because we have 2 is 3 times T, it means T is equal to 2/3. Very good. But what about this angle? That's the one I want. If I want to find the coordinate of P, I want the angle theta. So what's theta?
I mean,
Look at the picture.
can you assume that that's 2 arc lengths?
No, I can't assume anything because it's not 2 arc length. Look at your picture. What theta?
Oh, I see. It's
Just look at the picture, guys.
Would it be 90 plus T? I don't know.
Right, but it's not 90 because this is in region. It's going to be what?
Pi over 2 plus T, which is 2. So pi over 2 plus 2. Ah, okay.
That's what your theta is.
right.
That's what your theta is. And now, when you have your theta, you can pick up your calculator to make it easy for you. Remember, you cannot take 90 plus 2/3. The angle from this formula is in region. You have to stick to region, okay? And then you figure this out. So I don't know how much this is. It's 3 point whatever. Okay, I'm going to do it quickly. It's pi over 2 plus 2/3. I'm getting 2.237 region. Now I have my P, I have my theta, so the point P will have a coordinate 3 times the cosine of that, that's the x coordinate, 3 times the sine of 2.237. One of them will have to be negative. One of them will have to be positive because that's exactly what the picture is telling. Okay?
Okay.
It's a nice problem because it put a lot of ideas together. It put the notion of arc length and tells you that, if you want the coordinate of P, you have to figure out the angle between the positive x-axis and P. But this will give you only that piece, and then you can finish. So that's one way to do the problem.
Okay.
Okay, guys. Of course, time is up. Remember, the exam will open at 10:45, and I want the camera on during the exam. I want the camera on. Okay, and I have office hours tomorrow. It's on Bright Space. Please feel comfortable to come and ask me any question you want. All right. So time is up. If anybody has any question, you guys can stay. The rest of the class is dismissed.